Hi, here we are looking at the second part of your assignment, identifying subcircuits. So there are two parts to this. So the first part is to break the circuit down into subsections, like a block diagram would do. You may have a block diagram available to you. You may be able to find one. There may be some written in the schematic. You might not be able to do this part yet. In some circuits, you're not going to be able to do this until you're done with understanding how the schematic works, or at least a bit farther into it. However, if you can do this now, it will be very helpful to you in the rest of the assignment, because it allows you to know what each section of the schematic is actually doing within the circuit. In some cases it may be simple again, in some cases it may be difficult, not even possible at this point. But it's worth trying as part of this step. If you can't do it, just let me know you can't do it, that's fine. I will help you if it makes sense to. We'll just see how it goes. So a lot of this varies depending on your actual circuit. So in this case, we've got the full schematic of the 1176 I'm showing you. Now I'm just going to focus on a small portion of this, but this schematic is nice in that it actually gives you a little bit of a block diagram. So there are labels here. So there's T attenuator. Shows this input section, and that's a T attenuator. It's a special type of input control. Signal preamp. So this section of the circuit is a signal preamp. And this name just gives you a general idea, but it's a starting point at least. And then signal line amp here. So this part of the circuit is a signal line amp. And down here we have gain reduction control amp for this section. And then gain reduction meter driver amp over here. So that gives you a general idea. You can also look up for this particular circuit an actual block diagram, which you'll look at in a second. So here I've just highlighted in different colors the different sections of the circuit as are identified by the names in the schematic. If you didn't know how the circuit worked, you wouldn't be able to block them out like this. You know the general area, but separating each individual part would be difficult until you know how the circuit works. So again, some of this you might be able to do now, some of it you might not be able to do. Whatever you can do, though, will be very helpful to you. So here we have the block diagram of the circuit. And this is something you can look up online for the 1176 limiter that we're working on. You might be able to look up for yours. Just note that a large portion of what's on the internet is not true, so take it as maybe a recommendation and see if it seems correct to you. But don't necessarily know that it's actually, don't think that it's actually always true just because you find it. And that's true of schematics too. You will find schematics that have errors on them, that have mistakes in them. So if something actually doesn't make sense, come to me, we'll talk about it, and we can go from there. I'll be able to tell you if there's an actual schematic error or not. So this is a compressor. So there are really three parts that it has to have. It has to have a signal path, and a control circuitry path, and then something to do with actual gain reduction. So we come into the input, there's gain reduction, there's a preamplifier that amplifies after that gain reduction, and then an output section. So that's our signal path, going from left to right along the top. And then there's a detector. So that's what detects the audio signal, converts it to something that can control gain reduction. It would also be called the sidechain path. That sends something to the meter driver to let the meter know what to read, so you know how much gain reduction is going on. Now what's interesting about this particular circuit is that the gain reduction happens, signal goes to the preamplifier, and from there it goes to the detector. So that means that the signal that is controlling the gain reduction is the compressed signal. And this is one of the two types of compressors you'll see. The other type is to use the uncompressed signal to drive the detector. And as the channel strip we looked at, there was a switch to actually change between the two. But this helps you understand that the signal going to gain reduction, if you were to look at the circuit, you might say, well, wait, it looks like the compressed signal is going to control the compression, which doesn't seem right. So having a block diagram ahead of time would let you know that that is indeed what is going on. It might save you some time thinking there's a problem. So here's the preamplifier section, which is what we'll be looking at. And this already has the positive and negative paths labeled in red and green, positive and ground. So the second half of this is to identify subcircuits, things that we already know about. Common emitter, common collector, inverting and non-inverting op-amp circuits, common cathode, common cathode, common anode. Anything we've seen before, high-pass filters, low-pass filters, anything that you've seen before, even voltage dividers are worth noting. So you can refer back to what you know about those particular subcircuits. The reason we're doing this, and this is going to be a really powerful part of the process, because you already know how those circuits work. So if they're being used here, then you know how part of this circuit is working. So you just want to identify that subcircuit type. From that, you're going to mark and identify the components that have known functions. So if we have a common emitter circuit, for instance, if there's something in the place of R1 and R2, note that. Say, okay, R26 is in the typical place of R1, R27 is the typical place of R2. So you now know what R26 and 27 do. You know what those resistors do. So mark those. And then beyond that, identify mark components that you don't know. Okay, these are components that are not typical in our subcircuit as we've seen it. So you don't know what those are doing. And then identify the things that are missing. So for instance, if that R1 and R2 typical are missing, then you want to mark that down. And note, okay, R1 and R2 are missing. What do R1 and R2 do? They provide a DC bias voltage for the base that allows the entire waveform to be amplified. So you know that that's a function that still has to be met. If R1 and R2 aren't there, then something else is doing that function. At this point, don't look for what's doing that function. Just mark down that these are missing. This function has to be met, and it's not being met in its normal way, so something has to be doing that. So that's the basic goal of this process. And again, if you do this, you can get through a whole lot of the circuit and understand a great deal just by doing this, looking at things you already know. The goal of this entire process, the circuit analysis, is to understand what every component in the circuit does. So if you're looking at subcircuits you already know and identifying components as to what they do based on their original typical functions, then you start marking off those components because you know what they do. So here we have our preamp circuit. So in most cases, every active component you find will be part of a subcircuit, or will be the central portion of a subcircuit. So here I've highlighted the area around Q2. I'm going to look at the subcircuit that's involved in that. Q1 right here is actually the gain reduction portion of the circuit. So we're looking at everything past that. So this is our first active component, Q2. So that's what we'll start with. So first thing is to look at what's typical. Well, in this example, there's not much typical. There's simply one resistor. So the things that look typical exactly like they are in the subcircuit. And it's really important here that you mark what's exactly like it is in the subcircuit. If it's sort of like it, then you can note that, but you shouldn't identify it as being that typical component. So here we have R12. Oh, so we should start with identifying the subcircuit. So we have our input coming to the base. So that's coming straight from our input to this subsection of the circuit. Our output goes, well, how do we know where our output goes? So we have some more transistors here, discrete transistors. We've only looked at examples of circuits where the input is on the base. Common collector, common emitter, both have input going to the base. So the next transistor in line is Q3. Its base would be its input. And that means the output of Q2 is coming from the collector. Emitter goes down to ground and some other stuff. But this goes to the base of the next component. So our output is on our collector, meaning this is a common emitter circuit. Given that that's true, we have one component that's typical. R12 connects from the collector to a positive voltage. So that's there in the place of the typical R3, and it's converting and changing current to changing voltage. So R12 is the only component that we know actually what it does now. Q2 as well, we know that that's the main portion, the main component in this common emitter amplifier. So now all of these purple components are not typical. So now let's look at what's missing. So we don't have R1 and R2. Those are missing. They allow the entire waveform to be amplified, and they set 0 volts on the input to be halfway between saturation and cutoff. That's what R1 and R2 do. We know something else has to do that now. The resistor with the cap going from emitter to ground here is missing. So both that resistor and that cap are missing. So the resistor is there to combat thermal runaway, and the cap sets a low reactance path around the resistor for AC. So if the resistor is not there, the cap doesn't need to be there. So that part's pretty simple. And then we don't have any caps on the input or the output of the circuit, and those block DC from entering and exiting this. So no cap here for C1 and no C2 here, going between this and the output of the next transistor. Now, we looked at some circuits already that didn't have those, right? And that also were missing R1 and R2, some that were coupled differently. So that's something that worth looking back at. And you might even want to go back, and you might even be able to identify this a little more carefully based on that. But I want to just go with our real basic circuits. So don't forget that we looked at some other coupling types as well as common emitter, common collector with the caps on the input and the output. We looked at some other things too that are worth going back and reviewing in A112 if you had a discrete transistor circuit. So it's sort of worth looking at this point. This isn't part of the assignment, but it's worth looking here and saying, okay, R1 and R2 are missing. So there's nothing providing a DC bias in its typical way. That capacitor is also missing. So we're not going to block DC from getting there. There is a capacitor here earlier in the circuit. So if you want to think about that being C1, you could. But it's really not part of this subcircuit. If you identified that as the typical C1, I'd be okay with it. I don't see it that way in this particular circuit. So we need some DC getting here to bias the base, since R1 and R2 aren't there. So we have a capacitor here going to ground. That's certainly not going to be a path for DC. There's a capacitor here, so that's not going to be a path for DC. So R111 is the only choice. That's the only place DC could get to here. So we trace that back, and we get to part of the emitter path of another transistor. Well, we know that there's going to be current flowing through that transistor if it's working. If there's current flowing through that transistor, then these two resistors are going to drop voltage. So they're a voltage divider. So there's going to be some voltage sitting there. Since this is connected to positive voltage, this is ground, that means this will be a positive voltage of some sort, getting back to this base. So that's a path that could be providing the DC for this transistor. I'd want to know exactly how Q3 is working before I decided that for sure, but this is a good place to say, hey, that's something to look at when I get to doing this. That's a good starting point. And when you're here and you're looking at what's missing and what function they create, what function they're supposed to do, it's a good time to look for those other possibilities. Don't spend a huge amount of time on it because you'll get there eventually anyway. But when you're already looking at this in that sort of depth, it's worth taking a little time for any ideas you might have about how these missing functions are being met. So we've also got the resistor and cap from emitter to ground that are missing. Now we do have R13 and R14. And the reason I don't say that those are typical, there are two of them, but that could just make a bigger resistor. but there's a connection in the middle of them. That's definitely different. There's also a connection from the emitter going down to the output. That's different. So because of that difference, then I'm going to say that that's not typical. Now we do have this connection there. That's pretty weird. So none of this is really telling me anything, thinking about the standard common emitter circuit. Looking at that, I'm not seeing any easy way that thermal runner away could be gotten rid of other than our normal way of doing it. So at that point, don't stress about it, don't worry about it, just stop. If it's easy, like you say, okay, DC can't go there, DC can't go there, well, DC has to be coming here. Oh, that's a place where DC could come. If it's that quick, do it. If not, just move on and say, okay, I don't know what all these components do. And that's fine. We don't know what R11, C6, R13, R14, R15, R16 do. And that's fine. The point at this stage is not to know what everything does, is to find the things that you know easily what they do, and then move on. And you'll start to have a real good bunch of components done. Now I picked an example that didn't have a whole lot. If we look at Q3 and Q4 is up here kind of hidden, those have a lot of components that are typical. So you get a lot more information out of it. In this case, there are a lot missing, but it still seemed like a good example to show. And then our next step is going to be tracing the signal path, and I'll show that in the next video.